So in this lesson, we're going to look at Pythagorean theorem, and we're going to be able to identify what the hypotenuse is and solve for the hypotenuse or the legs of a triangle using Pythagorean theorem by the time we're done. Now, you've already done some algebra with Pythagorean theorem, so this lesson won't be new. We're just going to give you a couple extra problems, kind of a bit of a memory jogger. So this is usually one of the sections that people find a little easier, and then we'll be into vectors within 2 weeks. And this math was going to really come into play there. Vectors is where people tend to have a little more difficulty. But if you understand Pythagorean theorem well, and when we get to it, SOHCAHTOA, you'll find vectors quite straightforward as well. So everything kind of builds on each other. So first of all, we need to know what is a right triangle. So a right triangle is any triangle that has a 90-degree angle. So typically we'll use this square to show that something has a 90-degree angle. It just means that the two sides are perfectly perpendicular to each other. Okay? So because it has a 90-degree angle in it, it is considered to be a right triangle. That's what defines the angle, or defines the triangle. So Pythagorean theorem only works if you have a right triangle, meaning one of our angles is required to be 90 degrees. You'll often see it drawn in using this little square in the corner. If the triangle is not a 90-degree triangle or a right triangle, you will not be able to use Pythagorean theorem. There are some other trigonometry rules that you would need to use for that, which we don't cover in this course simply because they're typically not used in the trade context. So what is Pythagorean theorem? I'm going to guess most of you remember this. I remember the first time I was introduced to Pythagorean theorem. It was a grade 5 math enrichment class. Mr. McDougall was my teacher, and I had a picture on the next slide that is the picture that I remember for Pythagorean theorem. I can remember it like yesterday when we first figured out how Pythagorean theorem works, and I thought it was very cool. That was probably the start of me being as a nerdy math geek. So in a right angle triangle, what Pythagoras discovered, Pythagoras was, I believe he was a Greek mathematician. And I'm not sure what it is about sitting in their big common baths that they had, but that seemed to be where they would come up with all kinds of ideas. Now, if you do any research, some really weird stuff happened in those baths. So I don't know if just having a bath will clarify math for you or not, or if you have to have the really weird stuff go on too. But if you get stressed out with math, you can try the good old Greek mathematician bath scenario. So what he discovered for a formula was he discovered that a squared plus b squared equals c squared. Meaning, the longest side of the triangle, he said, is c. He also called the longest side of the triangle the hypotenuse. He found that if you squared the length of side A, so one of the legs, we call these sides legs, so leg A, and then you squared the leg B, if you added those two squares together, you got the square of side C. Okay? So we'll take a look at what exactly that means pictorially, but the important thing is C in this equation is always the hypotenuse. Now we typically write Pythagorean theorem as a squared plus b squared equals c squared. It could be x squared plus y squared equals z squared. That would be just as viable to write it. We could substitute different letters in, but this always has to represent the hypotenuse. HYP, hypotenuse. Okay, so the whatever they add up to is always going to add to the hypotenuse, because hypotenuse will always be the longest side. It's also a really good math check. So if you're doing a calculation and you know you're getting calculating the hypotenuse and it's shorter than one of the other sides, you know you've made a mistake. So it's a good little tool for checking. So this is the picture of what Pythagorean theorem means. He said if we took side A and we squared it, so we made a perfect square using that dimension, and a perfect square using side B, and I still remember this being drawn out with squares on the floor of the school, it would add up to c squared. So let's say B is a 3 by 3 squared. We'll say that A is 4, so this was a 4 by 4 squared. A squared would be equal to 4 times 4, which would be 16. B squared would be equal to 9. What would that make the other one have to be? Well, 9 squared, or 3 squared is 9 plus 16 equals 25. And if you were to draw this, the length connecting the two would measure out it's equal to 5. And you will find that 5 times 5, so 5 squared, is equal to 25. So this math does work out beautifully. 3, 4, 5 triangles are something that's often used in carpentry courses. They use that to check to see if an angle is square. You start at the corner, measure 3 feet in one direction, measure 4 feet in the other direction, and if the connecting line is 5 feet, you know you square. You're at 90 degrees. You could do 3 centimeters, 5 centimeters, and 4 centimeters. That would work as well, as long as it's 3, the ratio of 3, 4, 5 holds true. So that's one of those little things you can figure out. But I can still visualize this picture drawn out in squares on the classroom floor. Sometimes just remembering what those things look like can help you remember a formula. I will not give you Pythagorean formula, so you'll want to memorize that. So let's start with a couple example questions. I think I'm going to do 4 example questions if I remember right. I may have actually, yes, I have 2 number 4. So there's 5 example questions, and then we'll let you just do some extra practice in the quiz on Sam, so these won't take us too long. Calculate the length of side AB of this triangle. So side AB is basically just the point connecting A to B. So that's just another way of saying it or identifying the side. So we're looking for this side. Put an X there. So we have 2 sides. We're looking for the 3rd side. We notice here, this is a right triangle. So yes, we can go ahead. We could use Pythagorean Theorem, which links the sides of the 3 sides of the triangle. So A squared plus B squared equals C squared. Now I'm going to work at writing this down a few times because I want you to remember it. If it's not something you have memorized, write it down every time you use it. And by the time you're done, you'll have it memorized. So now we need to put in some information. So the first thing we need to do is find our hypotenuse. So you start at the right angle and you go across. The hypotenuse is always across from the right angle. So if you can't tell by looking that it's the longest side, you can find the right angle and then directly across from it. So this is your hypotenuse. We'll call it the hypot, just to save a few letters. Okay, now we know the hypotenuse value goes where C goes. So we'll put that in here. That's going to give us X squared. Now A and B, because it doesn't matter whether I go A squared plus B squared or B squared plus A squared, we can flip these 2 around. So it doesn't matter which we call. I'm going to say 5 is B and 9 is A. That's just because I remember a math convention with triangles for labeling, and it forces me to label that way. So let's plug them in. So we have 9 squared plus 5 squared. Now, important thing to remember is order of operations. Make sure you do your squareds first. So 9 times 9 will give me 81, plus 5 squared gives me 25. 5 times 5 is 25 equals X squared. Adding these together, we get 106 is equal to X squared. And remembering from our algebra section, we never leave our squared X. We have to take a square root. And X is equal to, we'll use 1 decimal place, 10.3 centimeters. You could argue with me that you could go with no decimal place there. We could say 10 centimeters or 10.3 centimeters. You can argue on the decimals since I haven't specified. I do specify on your worksheet, so you can practice rounding there. All right, so quite straightforward. So that one's nice and easy, no real rearranging to do. The one where sometimes we have people make a few mistakes is when we get to this example. And I think mistakes are just kind of careless rearranging. So write it down. So let's start out with writing Pythagorean theorem. We have our right angle. So a squared plus b squared equals c squared. Now that we know what our right angle is, let's label. And this time we'll use our a, b, and c. So 14 is my hypotenuse, so we'll call that c. And that means these ones could be a or b. So I'll call this one a, and I'll say this one is equal to b. And now we substitute in. So a is 6, so 6 squared plus b squared equals c squared is 14 squared. Expand those. 36, it should be a plus b squared equals 196. We need to move the 36, so we subtract it. Whatever we do to one side, we do to the other. And we are left with b squared is equal to 160. Take your square root to find out just b. B is equal to 12.6 centimeters. So the length of side XY is 12.6. Okay, so pretty straightforward. The reason people make mistakes with it is sometimes they forget to subtract the 36. If you get a negative sign when you're doing this type of math, it means you put your hypotenuse in the wrong place. So if you end up with a negative, let's say you ended up with a negative 160, that means you've done a rearranging error. So go back and check again. You can never take the square root of a negative number unless you know how to deal with imaginary numbers. And from my experience, most of us have enough difficulty dealing with real numbers that you'd much prefer we left out the imaginary numbers. Yeah, we'll leave imaginary numbers for a pre-calc course somewhere. All right, so just to do a couple of applied questions. These aren't exactly trade-specific questions, but they get us kind of thinking about it in a little different method. I will do at least one question that kind of touches on vectors. So here we want to calculate the perimeter of this trapezoid. So we know 3 of the sides, but we don't know the third side of the the fourth side of the trapezoid. So a question like this, try to find the right triangle. Now there's not the right triangle here, but if we break it and just draw a line straight down, now we have a right angle. So this would be our right triangle over here. We just need to find out some of the missing measurements. So we know this side has to be 5 because we've got a rectangle. And then down here, well, if this rectangle side is 6 centimeters and it's 9 centimeters overall, this must be 3 centimeters. Okay, so now that we have all of those pieces in, it's really straightforward to figure out X. So at first, we're gonna just deal with the triangle. We'll just deal with this section and then we'll come back and add in the other pieces. So in terms of our triangle, this is my hypotenuse. So Pythagorean theorem says a squared plus b squared equals c squared. C squared is the hypotenuse, so that's where my X goes. Equals, we'll say 5 squared plus 3 squared. 3 squared is 9, plus 5 squared is 25, equals X squared. We get 34 equals X squared. Take your square root. And we find that 5.8 equals X. So don't stop there. If that's where you stop, you got half the question, but you don't have it finished. The perimeter is equal to 6 plus 5 plus 9 plus 5.8. Adding all of those together gives us 25.8 centimeters. So just making sure, even once you've got your triangle, did you finish answering the question? Sometimes when we do things that require lots of steps, you get to the end of one of the first steps and you sometimes forget to go back and finish answering the question. The key in this question is we weren't asking for the length of that side. We wanted to know the whole perimeter, so you have to add in the extra information. Question 4, the first question 4. This is a really good vector question. You're going to have questions that look like this shortly. And then these questions, you won't deal with distances in your trade, but these are going to apply directly to electrical. We'll do them with distance first because distance makes it easy for us to visualize, where electricity is a little harder to see unless you've got an oscilloscope and all that kind of stuff. So Sam walks 100 meters north and then 150 meters east. How far is she from her starting position as the crow flies? So by as the crow flies, what I mean here is on the diagonal. Sometimes it's hard to describe that without having a picture drawn. So the first thing we do is we're going to draw a picture. So first of all, they go 100 meters north, and then, yeah, this is the right east. Then they go 150. Let me see if I can make this a little more to scale. Drawing straight lines is sometimes a bit of a challenge. I don't know why. It has something to do with drawing with my pen. So 150 meters east and then 100 meters north. And we want to know, well, how far is the diagonal distance that connects them? Okay, so what is that diagonal distance? So between north and east, we have a right angle. So what we want to do is, we're going to use Pythagorean theorem. We need to find where our hypotenuse is. So the hypotenuse is across from the right angle, so x is our hypotenuse, so we'll throw that in. And it doesn't matter where we put the other two, so we'll go with 100 squared plus 150 squared. Don't do 100 plus 150, you have to treat them separately, so we're going to end up with 10,000 plus, and I did not calculate what 1,500 is equal to, but I believe it should be, whoops, let me erase here. I'm going to work backwards from what I wrote in for my answers. If you disagree with it, please shoot me a message and let me know, and I'll re-record before I give it to anybody else. So here we would have 2,2,5,0,0 equals x squared, and 32,500 is equal to x squared. And now we take our square root of each side, and x equals 180 meters. So it's further to go across, the distance along the middle is longer than either of the two sides. It's shorter than walking around, which is why people often cut diagonals across lawns. We used to live on a corner lot, and people would often cut on a diagonal through our yard. They're just simply using the principle that going across the hypotenuse will create a shorter distance than going all the way around the outside of the corner. And one last question for us, question 4, number 2. To adjust and make this question 5. A 25-meter long guy wire is attached to a point 25 meters up the side of a tower. How far from the base of the tower is the guy wire attached? Draw a diagram. Now I say draw a diagram just because it helps us solve the question more easily. So first of all, we've got a tower. We're assuming it's vertical. We have a wire attached to that tower. So we have a 28-meter tower. Oops, 28 meter, sorry. Oops. There we are. I've got a lag in my computer here. There we go, back again. So we have a 24-meter tower, 24 meters up the side of a tower. 28 meters is my guy wire, so 28 meters is the wire. And we want to know how far from the base, so that's this line, what distance out is that wire attached? So let's figure it out. That's supposed to be a right angle, even though it doesn't look like it. We don't have a leaning tower. Our hypotenuse is the 28. All right, so start out with Pythagorean theorem. A squared plus b squared equals c squared. All right, A and B, it doesn't matter what they are. So 24, and we'll go with X equals, and C squared is our hypotenuse, that's the 28. Let's expand it. 24 squared is 576 plus X squared equals 28 squared is 784. Subtract, we have to move this to the other side, so we're going to subtract it. Now, the more comfortable you are with rearranging equations, you may find you skip a few steps. I'm assuming that you need a little bit of brush up, so I'm keeping all of the steps in here. But if you were to show a couple less steps, that would be okay, as long as you get to the same answers as what I'm getting. So 784 minus 576 left us with 208. So X squared is equal to 208. Square root both sides. And X is equal to 14.4 meters. So that guy wire is attached 14.4 meters from the base of the tower. Now, just quickly, before I finish off this lesson, steps for solving these. If you follow these steps, and these steps are going to go really well for the next trig piece that we do as well. First of all, draw a sketch. If you do trig without drawing a sketch, you are more likely to make a mistake. Draw the sketch. Trust me, it works. You don't want to do it twice. It makes it easy. Draw a sketch. Then find the right angle. If you know where your right angle is, that's going to tell you where your hypotenuse is. Then you can label your hypotenuse. Substitute things in the equation and evaluate the missing side. Now, when you get the missing side, always check to see if you're done. I didn't throw that extra graphic in, but those few steps will always get you on the right track if you follow them. I would argue drawing a sketch, if you're not given a picture, is one of the keys. Otherwise, people mix up which pieces are the hypotenuse and which ones aren't. And that finishes off that lesson. Next, we're going to start SOHCAHTOA.